Hello and welcome, a very warm welcome to the very first ever Workshop Wednesdays, Workshop Wednesdays #1. Today's session is on building modern camera features in Android using CameraX. Our sponsor today is Apptaura, the app development agency and experts in the south of England. I know they're brilliant because I happen to be employed by them. A little bit about me. I'm the speaker for today. My name is Tom Colvin. I'm, as I say, the CTO of Apptaura. And I'm also a Google developer expert in Android. If you have any questions, please let us know in the comments, and we will be glad to answer them. So without further ado, let's jump over to the presentation. So this is what we're going to look at today. This is building modern camera features in Android. We are going to start by looking at how we previously wrote apps with camera features, why that was difficult, why the process was a difficult one, why it was fraught with potential problems, and more generally, why anything to do with the camera is complex, why camera apps in general are difficult to write. And then we'll look at what CameraX did to change that and why it's a big step forward for us all. And then the bulk of what we're going to do today is the hands-on, and we're going to actually sit and write and build a camera app together, and you'll be able to follow along with the code. So the repository is at the bottom there. Go and get that. And you will need an Android Studio Jellyfish or later to open it. So let's have a look at how we previously used the camera in Android. So previously there were only two choices. Firstly, if you wanted to take a photo but you didn't really care how that happened, well, you had the choice of camera intents. An intent, obviously you're all Android developers, so you probably know this better than I do, but an intent is a message sent from one app to another, or across apps, or across different parts of apps. It's a message sent across the system that makes a request, and you can send a request, an intent across the system that says, I would like a photo, please. And any app that is capable of taking photos and willing to deliver photos back to you is able to put up their hand and say, yeah, I can do that. And you can and they will deliver a photo back to you. But you get no control over how that happens. You get no control over the UI that it presents to you. You get no control over the format of the image. You get no control over the features of the camera that are used. So it might, for example, use AI features. It might have emoji stuck all over it, which may be inappropriate to you. You get no control over that sort of thing. And of course, you get no control over the app itself that's running. So it's good. Camera intents are good for if you just want to take a photo or capture video with no control over how. Very, very simple. Absolutely no control over it whatsoever. Then completely the other end of the scale, we have the Camera 2 API. Camera 2 API, I was going to say it still exists. You can still use it. Camera 2 API is for everything else. And it is a very low-level API that is extremely complex to use. So what makes it complex? Well, the first thing is it's complex because anything to do with cameras is complex. Photography is a complex subject. So if you have ever played with an SLR camera, as digital SLR potentially, you'll know that there's lots and lots of settings involved, and the way different cameras respond to different settings. You don't necessarily have to set all those completely manually when you're working with Camera 2, but the way different camera hardware responds to those settings is difficult to predict and different across different manufacturers, different models, it's unpredictable in the way that the way that you'll get responses back. Photography is complex. It's also complex in that different models and manufacturers will send back the raw bytes from the camera in different ways, in different formats, and you'll be responsible for doing kind of combining that into an actual file that your app can read or send or do what it needs to. Video is also much more complicated even than photography, because you have two things that you need to manage, two different streams. You have a video stream and typically you have an audio stream as well, and it's up to you with this low level Camera 2 API to mix those two things together. And just as a demonstration of how complex working low level with a camera is, here is an example taken straight from the Google documentations in Camera 2, showing how you as an app developer need to implement front flash, and particularly the amounts of time between a flash and then the flash goes off, and then and then you actually take the photo. If you spend too long before you take the photo, then the subject doesn't have enough light. If you're too quick to take the photo, then there's too much light. You need to white balance at exactly the right point, otherwise the flash changes the color levels when the camera is pointing at it. It's crazy how much work you have to do just for a simple thing like a flash, and that's why I've put that that diagram there. It is definitely not something that you have to kind of learn by heart. And the other reason that Camera 2 is difficult to work with is that testing is complex. Testing is complex because different devices work differently. So, for example, if you have built an app using Camera 2 that works perfectly well on your Pixel phone, it may not work at all on your Samsung phone, or different features may be available and different features may break. And again, there are so many Android manufacturers out there that it's rather difficult to manage to write an app that works for all of them without actually individually having to test every single device there. And different Android versions, as well as different camera hardware, as well as different firmware within the phone itself and firmware for the camera, these all play into it. So even if you've got it working with, let's say, the latest Samsung Galaxy S series, you wouldn't necessarily still have it working in a couple of months' time where a new update comes to that exact handset. So Camera 2 is very difficult to work with. So that is why we have the CameraX API. That is why that was brought in. I'm talking as if CameraX is a new thing. It's actually a few years old, but it's taking leaps and bounds forwards, and there's constant development and constant work on it. So it always feels kind of fresh and kind of new, and there's always new features being added to it. So in the olden days, we had Camera Intense and Camera 2. These days, we have CameraX that goes in the middle. CameraX is now for the everything else, i.e. when you don't just need a simple photo capture with no control over the how. And Camera 2, which remains, CameraX is in fact built on Camera 2. Camera 2 remains, and it's there really only if you're writing camera apps for unusual hardware features. You know, if you've got a specific model of phone that you need to write a camera app for, then Camera 2 is the obvious the obvious choice. You know, maybe if you work for one of the handset manufacturers and you are writing the stock camera app, then you know, Camera 2 is the way to interact at the very low level with that hardware, and it's the only way to be able to access some of those features that wouldn't be available to CameraX in general. So we can conclude CameraX is the less complicated way to write camera experiences, but photography is still complex. So it's the less complicated, but still quite complicated way of working that. Like I say, don't worry, we're all in it together. That's what this workshop is about. We'll try and reduce some of that complexity, and try and make it so that it becomes a bit easier. CameraX then is good for exactly 4 things. One of the things that I like about the CameraX library is it's very clear what it does, particularly what it doesn't do. So it has 4 spheres of influence. It is good for, firstly, preview. So it is good for, you know, using your screen as a viewfinder, showing on your screen what the camera is currently pointing at. It is good for capturing images, so that is saving photos. It is good for capturing video, and I've hinted before that video capture is an enormously complicated thing because you've got the 2 streams, the audio and the video that you need. CameraX smooths all that out absolutely wonderfully. So it's a simple use case for video capture, saving video and audio. And probably the most exciting one, the image analysis, which is taking a stream of frames from the camera real time and passing them off to other workloads. So that's where you would pass it off to your AI workload, for example. That's where you would get to do QR code scanning. That's also where you get to build things like video conferencing apps. So taking frames from the camera and streaming them across the internet. So the image analysis isn't just for analysis, it's for anything that you want to do with the camera frame by frame that doesn't get saved in advance. So it's a real-time usage of the data that's coming from the camera. So let's move on to the app that we're going to build. I'll give you a demonstration of that. Let me load the app. Here we go. So this is the app running on a phone that's several years old, just to demonstrate that that it does work with not just the very most modern hardware. So this is a OnePlus 7T Pro, I think, literally from probably about 6 years old now. Here we go. So here is the app that we're going to build. This is me. Hi. So we're going to firstly be able to switch between cameras, front and rear camera, like that. That's what the rear camera is pointing at. And we'll be able to zoom by pressing these buttons like that. That's 0.5 and 1.0. And we'll be able to take a photo. And when we press take photo, it's going to pop up a sharing dialog so that we get to choose which app we want to share that photo to. So simple, simple, simple app. So let's talk a little bit before we jump into the workshop where we're going to do a sort of live coding demo and you can follow along. Before we jump into that, let's talk a little bit about the code and the pieces of CameraX that we're going to need to put together in order to make that work. So let me switch back to the slides just for a very short period of time. Here we go. So CameraX, as I said, is built on 4 use cases, and those are objects. Those are objects that you will create yourself. You will create a preview, an instance of the preview class, instance of image capture, video capture, image analysis, as you wish. The other object that you will create is a preview view. That is the UI element that you will stick somewhere in your the UI of your app that will get filled in by CameraX with what the camera is displaying. So we will create a preview view. Then these use cases each have their own methods. It's worth having a look, digging in a little deeper into specifically the functions that they provide, but just the very simplest parts of them. So for preview, the very simplest part is set surface provider. So that is that sets which preview view the preview use case is going to deliver its camera data to, and what you get is a filled-in preview view, just like that. Image capture has a function called take picture, which takes a picture. Video capture, again, video capture is a little bit more complicated always than image capture. So you get an object, an instance of class called recording out of the video capture, and you use that to manage the recording. And image analysis, the key method there is set analyzer. But as I say, there's more to it than just that. Those are the very most simple things. Now, those are just the use cases, but you also need to bind it to a camera and to either a front-facing camera or a rear-facing camera, and to the CameraX library more generally. And for that, we have this class that's called camera provider. So what we do is we create a camera provider. Actually, we ask CameraX library for an instance of a camera provider. And we take the use cases that we want, any of the above. By the way, preview is a required one. All of the others are optional. And in fact, on some phones, it's you're unable to use some use cases together. So you have to be a little bit careful about which ones you pick. For example, only some phones are able to do image capture during the time that they're doing video capture as well. So you have to be a little bit careful to choose only those use cases that you actually need. So we have the use cases and the camera provider, and the main method that we get, we get a camera selector as well, which is the thing that picks whether it's a front-facing camera or back-facing camera, or some phones have many different cameras beyond that as well. So you pick a camera, and then it all gets bound together with the glue of the camera provider, and this method called bind to lifecycle. Once you've bound all of that together using that method, then everything just works. So let's move over to our code then. Okay. So here we go. So here's a blank repository. You will hopefully see if I let's stick my output back here. Okay. Hopefully this is large enough for you to see, and small enough that it actually all fits nicely on your screen. That's what I'm hoping for, but let me know. Let me know if there's any issues. Right. So the very first thing that we want to do on our camera app screen, so we've got I've gone into main activity, by the way. This is main activity here, and we've got a composable called camera app screen. So if you run the app for the first time, it's going to ask for permissions, and I've done all the boring stuff around permissions. I'm assuming that you guys as Android developers know what you're doing with permissions, but if not, there's some code to explore there, and come back to me after the session, and I'm more than happy to talk to you in far more depth than you are probably interested in about how permissions work. But we are going to start with a preview view, which we are going to fill in later. So let's remove that for now. And what we're going to do is create a preview view. So one of the bad things about CameraX is that it is strongly focused on XML. These are XML components. These are not nice Jetpack composables, which is a little bit frustrating. But it's only the preview view, so we will create an Android view like so. I don't know if you are familiar with how we create an Android view within a composable. It's code that maybe you'll have to use once or twice in your life. I'm not going to go through it in a lot of depth here because it's sort of outside the scope of this particular session, but hopefully you'll have to use it less and less as time goes on, as everything becomes more Jetpack composy. So what we have is we have an Android view. Let's tell it that we want it to fill the entire screen. Thank you. Yes, the viewfinder for Compose is already in alpha. That's good to know. Yeah, they are updating this this library constantly, and it's there's a good team working on it, and there's regular updates. The stuff in alpha is not usually fantastically stable, but it shows where it's going, and it does move very, very quickly. So alpha to beta to release candidate moves at a decent pace, particularly for Google. So back to our code, we're going to create this Android view. We're going to tell it to fill max size because we want it to fill the entire screen. And this factory method is what we use to create the composable. Sorry, the component, the XML component that we're sticking inside our composable. So in this case, we want to preview passing in context like so. So now if I run that app, we're not going to see very much. We're going to see a black preview. Look at that. We are not getting any feed because we haven't attached that preview to anything. So that's going to be the next thing that we do. So what we need is a preview use case. And the best way to create a preview use case is using by remember. Use case. And of course, remember preview. Now, the slightly frustrating thing here is that preview already exists in Jetpack Compose, the word preview, the class name preview. So we have to specify it completely using its full package. So we will create that preview using .build like so. Preview, sorry, it's preview .build like that. So we have a preview use case. And we will tell the preview view that we're creating here to use that preview use case. So we will say also preview use case dot set surface provider it dot surface provider. So that means that it here is the preview view that we've just created. It has a surface provider, that is the surface that we're going to paint onto. And we're going to say that the preview use case we're going to pass that surface provider to the preview use case. So the preview use case knows where to sort of paint its pixels. Okay, if we run that, it's still going to be black. Never mind. The reason that it's still black is we don't actually have a camera provider. to bind it to. So remember that. Remember that view that we saw, that slide that we saw earlier, where it's the camera provider that kind of binds everything together. So the piece of code that we need for that is we are going to create a camera provider. Var camera provider by, remember, mutable state of process camera provider. Oops. Mutable state of process camera provider, like that. And we're going to actually create it a little bit later. No. And always needing the control ones. We got that. Okay, so the camera provider is an abstract class, and the concrete version of that is a process camera provider that we're going to need to create. So we're going to do that the very first time this this composable appears on the screen. So when it's added to the screen. So the way we do that is with a launched effect with a key of unit. And the particular code that we need, I'm going to copy and paste it so that you're not having to wait for ages whilst I type. The particular code that we need there, in fact, is like this. So we need to start with a local context. Local context equals local context current. Okay. So launched effect unit, this code is run the first time that this composable appears in the layout. What we are doing is, again, this is something that really could do with using Kotlin coroutines or using a suspend function or something like that. We've got something separate to that here. We've got its own future class, which provides, you know, here we say we want an instance of a process camera provider, and it's going to provide it later. So we have to add a listener for that thing that is that it's going to provide later. Once we are told that it's available, we go and get it, and then we set that to the camera provider there. And we have to tell it which executor to run on. Again, I'm hoping that somewhere down the line, main executor, we're not going to have to worry about executors. That's going to be something that that Kotlin can take care of. But for now, this is very much a Java library. So the final thing that we have to do is bind the camera provider to bind the use cases to the camera provider. I don't know if you've noticed, but there's a potential race condition here. And so we've got to be a little bit careful about how we bind things. So one of two things could happen first. Either the process camera provider becomes available via this add listener, or the preview view is created according to this factory. So either one of those could happen first. So what we need is what we need is to have a separate function that does the binding for us that we can run on either of those cases. So the way we will do that is write a function. Kotlin now allows us to do this. It's called, let's call it rebind camera provider. And what we're going to do is rebind the camera provider when the preview view becomes available. Rebind camera provider like that, and we're going to rebind it after the camera provider becomes available. Sorry, did I say camera provider before? I meant the preview view becomes available. So this function will be run when everything is available, and we want to make sure we want to use it to bind the use case, the preview use case that we've created. We want to bind that with the using the provider. So we will do camera provider (let) to tell us if the camera provider is actually available at this point. If it is, we need camera provider .bind to lifecycle. Our lifecycle is local context, but we have to tell it is a lifecycle owner, which it will be in our case. We need a camera selector as a second argument. I will come to that. And the last argument is the use case or use cases that we are binding in for this instance. So for us, it is the preview use case. So what's this middle argument, this camera selector? Well, that tells us which camera we're using within the device. So a camera selector is like this: camera selector equals camera selector .builder. We tell it what camera we want, like so. Require lens facing camera selector lens facing front. So we are telling it to use the camera whose lens faces the user. And we are building that camera selector, and we will pass it into the camera provider like so. Now, bit of a drum roll, because you know these things never quite work out, or potentially don't work out when we're doing something live. But let's see. We're going to press the button, and I hope the preview is working. Yay! There we go. So unfortunately, you get to see my face more than once, but there we go. We got the preview view working. So I'm going to take a little pause there. Let's get rid of my second face. I'll take a little pause there. Does anybody have any questions to ask? Go ahead, Oscar.
Yeah. Thanks for the workshop so far. I was wondering, see, now I have a Pixel 4a that I run this app on. Is the CameraX API providing the same sort of viewfinder that I would have from the Google Camera app? Or is that app, for example, plugging into different native APIs that they have for Pixel smartphones and doing processing there?
Yeah, so the Pixel camera app will have features that that are not available on CameraX, because they're very specific features to Pixel. I'm sure it's true of other manufacturers, but I think it's particularly true of Pixel, which is a brand that sells itself on its smart camera and its its AI capabilities and things like that. CameraX isn't about that. CameraX is about providing a lowest common denominator that can get any camera from any device it supports working with a base set of features. Now, there are other extensions that you can plug into. For example, you can ask it if it supports portrait mode. You can ask it if it supports a couple of use cases all at once. So the Pixel, for example, you can take photos whilst you're recording video. And you can ask CameraX if those sort of things are supported, and you can use that kind of thing. But it's not going to support all of the things that the Google Camera app supports, simply because that's Google's proprietary technology, and they don't put that into open source libraries.
Okay, thank you.
So Malik, you asked, explain the rebind camera provider. Yeah, so the idea of rebind camera provider is well, it's a method that binds using the camera provider instance. So the camera provider is the glue that sticks everything together. So it uses that glue to stick together these specific things. The camera that we're using, which might be the front camera or the back camera, or there are some devices with many different kinds of camera. So it glues that together with the use cases. In our case, we've only got one use case. We're going to increase that later. So the idea of the rebind camera provider is that it uses that glue to stick everything together and make it all work. The reason that we've put it in a separate function is because we need to call that from two different places within our composable. The first place we need to call it from is when this provider, the process camera provider, becomes available, because that is the glue itself, but it takes a little while for that to become available to us. We can't just ask for an instance of it, we have to wait for an instance of it. So when we've got that, we call rebind camera provider just here. And also we've got the Android view, which can take some time to appear on screen. When we're saying some time, it's milliseconds, but it's not instantaneous. So we have to call rebind camera provider there. One of those things, one of those rebind camera providers will be called last, and that's what actually ends up binding everything together. The preview view, the preview use case, and the camera selector, all bound together using that camera provider. Yes, and Costas makes a good point in the comments there. Okay, so now that we got a preview, we might as well add a camera selection button. So the way that we're going to do that is say that this camera preview, the camera app screen is going to take an argument. But before I do that, I'm going to do a little bit of UI rejigging, because what we want to do is put some buttons on top of our preview view. So let's start like this. Okay. So within the camera app screen, now it's completely blank. We're going to stick a box. Again, this is Jetpack Compose code. It's, if you are not familiar with Jetpack Compose, don't worry. I know it's just a sort of copy and paste job at this point. We'll perhaps have other workshops on Jetpack Compose, but for now it is just a copy and paste. So we're going to stick a box in which one of the items in the box is going to be a camera preview, and the other item is going to be a column in which we can start placing buttons. So a row of buttons. In fact, let's make sure that that column gets stuck to the bottom of the screen. Like that. Okay, and let's give ourselves a row of buttons using which we can select the lens that we are using, or the camera that we're using. I'm going to copy and paste this code because there's no value in me typing it out and explaining as I go. Okay, so we've got a button on click, we are setting this lens facing variable, which you see in red at the moment because it doesn't exist quite yet. But basically we got button for front camera and button for rear camera. And if I add the variable here, we want just a var lens facing by remember mutable state of camera selector dot lens facing. Let's say the default is the front. In fact, it's going to want mutable int state of in this case. That's the preferred way of having a remember with an integer. Okay, so we've got a variable that is set to lens facing front or lens facing back, depending on the button that you have clicked. So what we're going to want to do is pass that into our camera preview function, lens facing, like so. And we'll pass it in like this, lens facing equals lens facing. Okay. So how are we going to manage this lens facing variable that we have passed in as a parameter? Well, we are going to use camera selector here. At the moment, it is require lens facing and it's hard coded to front, but we're going to say lens facing like this. So we use the value that's passed in. Now, if we run this, we get an interesting crash. And I particularly want to show you this crash because it's worth explaining how this stuff works. So we see that we've got the front and rear camera buttons, but if I press for the rear camera like this, okay, I'm not even getting a crash. Now, why am I not getting a crash? Can anybody see what I've done? Oh, I know what I've done. We need to have a launched effect for when this lens facing lens facing parameter has changed. So when lens facing changes, we want to rebind the camera provider again. Now we're getting to the point where we'll get the crash. That's progress, you see. Okay, so if I press rear camera, we see that we get a crash. If I check in my logcat, the crash is that the preview is already bound to a different life cycle. What that tells us is that up here where we are, where we're binding, where we're doing bind to life cycle, we can only do that once. We are only allowed to bind to one life cycle. If we try and do that again, like we did when the lens facing changes and we ran the rebind just here. If we try and do that again, then it's not going to dispose of it manually. These are the sort of weird little things that we are having to do on a manual basis. So what the solution to that bug is very, very simple. We just need to tell it to unbind everything. So we do camera provider dot unbind all. And now we should have an app, but when we run it, yoink, will give us the front or the rear camera, which it does. Awesome. So take another pause. Are people following? Are you guys able to follow what I'm doing? Are you do you have that stuff in front of you? Are you coding along? Let me know. Zayn Malik, go ahead.
Hello, you can hear me?
Yes, I can. Hi.
Yes, so as much as you will make the, if for example, I remove this unbind all, as much as I will make the buttons, so it is because of the buttons I'm creating, or it's because of the launch effect I'm creating, the crash?
The crash exists because you are running rebind camera provider. It's because of that launch effect, obviously, is the thing that's running now. It's because you're running rebind camera provider at the time that the camera provider is already bound to something. It can only be bound to one thing at once. So that's why we have to make sure that it's unbound before we run the bind to life cycle. It's that method, that specific method, bind to life cycle, that matters in terms of what's bound where.
Okay, thank you.
No problem. All right. Wouldn't the crash be also possible in the earlier scenario when we were already calling the method twice? Potentially. The answer is potentially. What is stopping it from crashing is because we've got camera provider (.let) there. And because things actually happen in the right order for us, you know, we essentially got lucky with that race condition, but it could have done, yeah. So we want an unbind all in that place. But yes, you're absolutely right. Okay, so we're going to move on to Zoom, unless anybody has any further questions. Now let's move on to Zoom. Okay, so the way that we manage Zoom is with a camera control instance. So I'm going to create a remember for that particular variable, but then I'm going to show you where we get the actual instance of camera control. So bar camera control by remember mutable state of camera control question mark, and we set it to null to begin with. Okay, so that is the variable that we're going to use throughout our code. But the way that we get it is on return from bind to lifecycle. So bind to lifecycle gives us a camera object. Camera equals that stuff. So this is a camera object. And if I do camera dot, it's a shame you can't see the autocomplete there. That seems to be in a different window, and Google Meet's not picking it up. But there's a number of things, and I at this point I would urge you to I'd urge you to go ahead and just play with those things, just see what they do. So there's an object called camera control, which is the one that we want, but there's other objects called camera info and camera internals and extended config, and it's worth just playing with them. They're fun. They're easy to work with, and the library is very stable. So you know, you can't screw things up. Anyway, camera control is the one that we want, and we want to set that our camera control variable to that, like so. Camera control equals camera control. Now we want our camera preview composable to take a zoom level argument, like so. And with that zoom level, we are going to have another launched effect. So launched effect on every time zoom level changes, we are going to run this code. And the code that we're going to run is very simple: camera control dot set linear zoom or zoom level. Okay. So we're going to have a syntax error here, obviously up here, because we've added a new parameter which we have not dealt with here. So let's put in our zoom buttons again. I'm going to copy and paste this because there's no real value in talking this one through in depth. But if we create a zoom level variable right here, var zoom level by remember mutable float state of 0.0 f, and we'll pass in zoom level like that. Okay. Oops, I've put val and I meant var, and I've got a syntax error as a result of that. Okay. So we got 3 more buttons in our layout here. One that sets the zoom level to 0, one that sets it to 0.5, and one that sets it to 1. So the zoom level fully zoomed in is 1.0 and fully zoomed out is 0.0. And the actual method is set linear zoom. It doesn't feel very linear, frankly, when you use it. It seems a lot more than linear. It seems rather an exponential zoom, but that's there's a number of effects that combine to make it look that way. But if we press play on this, we should now be able to have a zoom. Okay, so it's on zoom 0.0 at the moment. If I press 0.5, I get bigger. And if I press 1.0, oh, sorry about that, we get even bigger still. So there we go. We've implemented zoom, and the way that we implemented zoom, just to go back over that, is camera control.set linear zoom. Okay, questions now on when we'll get the recordings. I will make them available. Essentially, I'll hesitate to say immediately because they need to be topped and tailed, and actually takes a little while for Google Meet to make them available anyway. But 48 hours maximum. And I'll let you all know. I'm going to create a YouTube for Workshop Wednesdays. Obviously, this is the first one, so it doesn't exist yet, but I will, in future Workshop Wednesdays, I'll say it's available on our YouTube. So the very last thing that we want to do is take photos. And what we need for taking photos is where we have a bind to life cycle here. We've talked about a preview use case just down here. That is the only use case that we are binding at the moment. We actually need an image capture use case, but we need to use that image capture use case outside of the camera preview. So I'm going to pass it in as a parameter. There are different ways of managing this. It's not that satisfactory to me to have it not symmetric with the way that we have a preview use case, but we'll go with it for now. And exercise to reader is to improve the architecture of that if you so wish. So we'll pass in the image capture like that. And we will use the image capture use case to bind as part of the bind to life cycle here. We will define it in the parent composable, like so. So we will remember an instance of image capture that is built using builder.build. And our camera preview will pass in the image capture use case. Like so. So now we've got an image capture use case that is passed into our camera preview just here and is bound again using bind to life cycle. Here is our list of use cases. And then for the grand finale, this is the grand finale. This is we are 1 minute away from 6 o'clock, at least in the UK. So we are maybe going to overrun by about 40 seconds, but let's see. Let's add a button to our layout, which on click fires off that image capture use case. So again, button on click equals something, and we'll give it a text of take photo, like that. So what do we need to do on click? That's the last thing that we got to do in this workshop, and then I will leave you to ask questions if there are any remaining. So the way that we manage that is we do image capture use case dot take picture. There are 3 arguments to this. There's an output file options. You can see the tooltip there. That's good. You can see the output file options. There's an executor that it's got to run on, and a callback for when an image has when a photo has been taken. Either that or an error has occurred. So let's put those arguments in one by one. So the first one is the output file options. That comes like this: val output file options equals image capture dot output file options dot builder. Here in the builder, we pass it where we want the file to go. On builder mix, we pass it where we want the file to go. Which in this particular case, I have set it up with a little bit of background magic, so it can just go in local. Ooh, I'm going to need my context. Excuse me. I'm just going to go up one here and say val local context equals local context of current. Okay. So back down to my code here. So we're going to say that the file is in local context.external cache directory. And we'll just call it image.jpg. So that's our output file options. Our executor is simple. Our executor that we're going to run this on is context compat.get main executor for our context. And finally, we've got a callback. So the callback object, which tells us whether we've succeeded or not, is looking like this: val callback equals object colon image capture dot on image save callback. Okay, so we got 2 things that we can implement out of that. So if I just alt enter and say implement members, those are the 2 members that we need to implement. On error will leave as an exercise to reader, but on image saved will give you an output file URI. So that is the file that is saved to the disk. And via a little bit of magic, I've put a share as image local context. Again, not something worth going into in here, but if you've ever done any sharing stuff on Android before, you know that's just one of those things that's weirdly complex on this platform. But the output file results will give us a saved URI, and we, via the magic of this function, which again, because you've got the repository you can go into, you can see how that works, get shared as an image to whichever app wants it. So now if we press play on this, yes, here we go. We need to actually pass it that callback. Let's press play again. So this is the grand finale. Hopefully, if everything has worked, then this take photo button will pop up that list of apps that might want a photo to share. So kind of drum roll, please, where we've overrun by just a couple of minutes. So hopefully it's going to work first time. Pressing take photo now. There we go. So I can press save. There we go. Okay, so that's kind of the end of the workshop. Does anybody have any particular questions, any further questions on what we've done? Yeah, so the a request there to commit the finished code. It is actually already committed, so I did that last night. There is a second branch in the repository that you have cloned, which is called working steps, and each commit within working steps is it followed what we did in this workshop. So each commit is one little step on from that. Yeah, the repository link is, if anybody has access to that quicker than I do, then please paste it into the, yeah, thank you very much. There we go. Oh, you rock. There's 2 of you done it already. Fine, excellent. So any further questions? That sounds good. Okay, so nothing further from this end. I hope you've enjoyed Workshop Wednesdays. Keep an eye out. There will be, like I say, another Workshop Wednesdays in 3 weeks' time. We're going to do it every 2 weeks, but the next one will in fact be in 3 weeks, because in 2 weeks we coincide with Google I/O Connect, and certainly in the Europe region where I am. So 3 weeks' time, the next one will be on the 3rd of July. Thank you so much, everyone, for making it. Really appreciate you sticking around. Really great to have you. Yeah, I hope you've enjoyed it. Please, please, please do give me feedback. I'm really, really interested to hear how you to hear what you thought, and to know whether this was useful for you, and also to hear whether there's other subjects that you might want to do in a workshop. You know, we haven't chosen a subject for the one in 3 weeks' time yet, so come to me and let me know. Thank you, everyone. Appreciate you coming. Oh, we have a question. How would you approach writing tests for these features, given that this is so tied to the platform? Yes, it is tied to the platform. The answer is end-to-end testing. I really don't think there's anything that's unit testy that you can do with this. The way you test it is by putting it in your hand and pressing the buttons. It's frustrating, but there's no business logic here. It's all UI logic. There's nothing that you can pass out into the any layer that is higher level than UI. So you test it by doing it, and the most important test, in fact, is running it on any device that you know that your customers have. It's not necessarily about testing functionality; it's about testing compatibility. So if your customers have sort of weird, as one of ours do, weird handheld devices for delivery drivers, then test it with that, because that's important. Wonderful ideas on workshops. So broadcast and services, security, and Android is one of my favorite topics. So if you ask me for a workshop on that, you will be there all night and the next day as well. So I will gladly do that. Maestro and snapshots, another great idea. Thank you for that. Okay.
That was for the testing, but okay.
Sorry, go ahead.
That was for testing, but okay. Because you mentioned end-to-end tests and how to test the camera APIs, maybe instrumented tests with a fake image. But yeah, then again, I don't know how you snapshot the output. It's kind of a weird thing to test.
You're absolutely right. You're absolutely right. Yeah, you can't fake this stuff, because it all sits in the low level. You know, if you like me, if you like clean architecture, then everything is on that outside ring, and that outside ring is not really testable. Yeah.
Thank you.
That's where we are with that. Thank you. Again, thank you very much, everyone. Another 5 minutes if anyone wants any more questions, but if not, we'll wrap up. No, sounds good. Okay, again, thank you very, very much, everyone, for coming. Appreciate it. And I very much hope to see you at the next one. Take care. Bye-bye all.
Thanks, Tom. Cheers.
Cheers. Bye-bye.